Okay, I had a couple of homework questions from page 414. So the first one here is number 6. We're finding the area of a parallelogram formed by vectors p and vectors q, but they're actually giving us the answer is the square root of 35. So we know that the area of a parallelogram is equal to the magnitude of the cross product of the two vectors. Now we know that the area is root 35 in this example. And then we'll figure out the other side. It's going to have this variable a in it, and then we're going to isolate and solve for a. So first we'll do the cross product of the two vectors. So it'll be the third times the second minus the second times the third. So I'm just looking at the second coordinate times the third coordinate for the cross product. And then for the next coordinate, it's the third times the first minus the first times the third, so that's 2a. And then we've got the first times the second, so that's a, minus the second times the first one. And then we want to find the magnitude of the right-hand side, so we'll take the square root, and then we're going to square each of the coordinates. So the first coordinate ends up being -3 squared, and then we're going to add the second coordinate being squared. And then we'll add the third coordinate being squared. Now, since the entire left side is being square rooted and the entire right hand side is being square rooted, we know that it's just that 35 is equal to this stuff under the square root on the right hand side. So I'm going to simplify that out. I've got -3 squared, that's 9. And then here, don't forget that this is a bracket being squared, so I should end up with 4 terms when I do this. So I'm going to get -1 times -1, because the second, so you could even write it out if that helps. So I have to do -1 times -1, that gives me 1. And then -1 times -2a, that's positive 2a. But then when I do this one here, I also get positive 2a. So altogether that's plus 4a. And then -2a times -2a, that's plus 4a squared. And then the third term here, I've got a minus 1. So again, if you need to write out the bracket twice and actually drawing the arrows, I'm going to get a squared minus 2a plus 1. And I'm adding that. You can put the brackets around that if you want, but it doesn't make a difference because you're adding. And so now I'm going to try and collect my like terms. Over here I've got 5a squared, and I've got plus 2a, and then I've got 9 plus 1 plus 1. So I've got a quadratic to solve, and in order to solve a quadratic I need to set it equal to 0, so I'm going to bring the 35 over and subtract it. And so I get 24. There's no common factor here, so I'm going to be looking for two numbers that, oh, I wish I'd brought a calculator for this. 24 times 5, so I need two numbers that multiply to -120 and add up to 2. Oh, 10 and 12, right? Yeah, 10 and 12. So it'll be 12 and -10 because I need it to add to positive 2 and multiply to -120. So that tells me I can use decomposition. If you didn't see it, you could use quadratic formula and work it through that way. You can do the 12 or the -10 first, it doesn't matter. So I'm decomposing the middle term into 12a minus 10a. There are other strategies for factoring complex trinomials, but we usually use decomposition. So decomposed there. And then I'm going to look for a common factor in the first two terms and a common factor in the last two terms. So I've got a and 5a plus 12. And over here I can take out a common factor of -2, and that leaves me with 5a plus 12. And so I get a minus 2 and 5a plus 12. And then to solve this, because I have two brackets being multiplied that equal 0, either the first bracket equals 0 or the second bracket equals 0. And so either a equals 2 or a equals negative 12 divided by 5. So those would be my two values. The second question that I got was in R cubed, we've got the 3 points A, B, and C that form the vertices of a triangle ABC. We're going to construct position vectors AB and AC to help us find the area of the triangle. So remember that these are not vectors up here, these are just points. So we have to find those vectors first. So for AB, if I want the head to be at B, I have to take the B coordinates and subtract the A coordinates. So I'm going to get 1 minus negative 2, and then 0 minus 1, and then 1 minus 3. So there's my AB vector, and then it asks us to find AC. So I'm going to do the same process, just the C coordinates minus the A coordinates. So I get 4, 2, and negative 1. And now that I've got these two vectors that represents the sides of the triangles, I can actually find the area of the triangle, which we know is 1/2 times the magnitude of the two vectors cross product. I do have the vectors here tail to tail, so we like that. So I'm going to find the cross product of these two vectors. So I'm doing the second coordinate times the third minus the third times the second, and then the third times the first minus the first times the third, and then the first times the second minus the second times the first. And then I'll simplify that vector. And then I'm going to take the magnitude of that vector, so the square root of each coordinate being squared. And I've got the half tagging along here, right, because we're dealing with a triangle, not a parallelogram. So I'll deal with that at the end. So what do we get here? 25 plus 25 plus 100, so 150. And 150, we're going to try to simplify that, so that's 25 times 6, so I can pull the 25 out, and then the 6 will stay under the root, and so I get 5 root 6 over 2, or 5 halves root 6. And then you would do a similar idea for part B. You're just constructing two different sides of the triangle, and then find the area of that, and then drawing that conclusion. You should get the same answer on both.